Okay guys, right now we're doing just a quick review on how to draw molecular Lewis structures. A couple units ago we practiced drawing Lewis structures for atoms based on the number of valence electrons, but this is for drawing the Lewis structures for a molecule like H2O or CO2 or something like that. So we have 5 simple steps, kind of like a set of rules or tricks to get us the Lewis structure every time. It's kind of like a puzzle, but this is a set of rules that will get us to the correct structure of each of these molecules. So first step is to count the valence electrons. We'll do a quick review of that. How to count valence electrons for an atom, and then we're going to add them all together to find the molecule. And then I'm going to add here just if charged. You hopefully remember that if something has a charge, we call it an ion, and that means it's either gained or lost electrons. So if it's gained electrons, we need to adjust for more valence electrons. If it's lost electrons, we need to adjust for less valence electrons. So there's our first step. Then you're going to say, I'm going to say we're going to draw the skeleton. When you draw the skeletal structure, the first atom goes in the center. The exception is hydrogen. So in the case of like H2O, even though hydrogen's first, it'd be oxygen that goes in the center. But for any other element in a molecular formula, that first compound is going to be the one that goes in the center. Then you are going to, make sure I note this, subtract 2 electrons per bond. Hopefully remember that each bond is consisting of 2 electrons being shared. So we're kind of keeping track of our total. In step 1, we got our total valence electrons. Step 2, we drew the skeleton, but if I drew 3 bonds, for example, 3 times 2 electrons per bond, that means that I've drawn 6 electrons in my molecular structure. So I'm going to need to subtract 6 from my total to see how many I have left. Step 3 is you're going to complete the octet. Octet again meaning 8, on the bonded atoms. Bonded atoms are the ones around the center. So each of those around the center is at this point going to have 2 electrons because they each have a bond to that center atom. But we're going to complete the octet, which again usually means putting 6 dots representing 6 more valence electrons on each of those bonded atoms. And when we do that, we're going to again subtract from the total. Okay, I'm going to put subtract E minus, subtract electrons. Sorry, that's a little outside the parentheses. Number 4, any extras. So at this point, if we have any extra valence electrons, those go on the center atom. Okay, so if we have 2 extra valence electrons, they go in the center. If we have 4, they go in the center. And just as a side note, if you end up with an odd number of extras, you did something wrong. Go back, recount your valence electrons, redo your math. You should always end up with an even number. As a hint here, I'll write that down. This should always end up as an even, if any, or 0. 0 is sometimes valid, but it should be even or 0. Okay, and then I'm going to say the last step would be to check. Can't write. Check for octet on center. Make double bonds if not. So you're going to check that the center atom has an octet, and you're going to, well, we'll deal with that, but you need to end up making some double bonds to redistribute some of those valence electrons. So here's our 5 steps. First step, count valence electrons. Just do a quick check looking at our periodic table here. Not to go too in depth, but if we go back to electron configurations, everything in this first column, those will all be something S1. So like hydrogen would be 1s1, lithium would have 2s1 in terms of their valence structure. So these would all have 1 valence electron. Okay. Second column here would be something S2, so these would all have 2 valence electrons. These here would all have 3 valence electrons, and then so on. So we end up with each column, therefore, in the S and P blocks having 1 more valence electron than the one to its left, with a maximum of 8 valence electrons for those noble gases. So that's just a quick review. So let's jump in, let's try some. So if you see something like CCl4, you go, okay, well, carbon has, if you see up here, find carbon. Carbon has 4 valence electrons, and chlorine has 7 valence electrons, but there's 4 of them. So I'm going to go 7 times 4, 7 electrons times 4 equals 28 electrons. Okay, sorry I did my math kind of like off to the side, but we're doing 4 plus 28 would give us 32 valence electrons total. So there's my step 1. Then to draw my skeletal structure, carbon's the first, so I put it in the center, and then I distribute the chlorines around. So I'd end up with my 4 chlorines distributed around kind of in a cross shape. And then I have to remember to subtract. Each of those bonds has 2 electrons, so if you count 2, 2, 2, and 2, that's 8 electrons that I've just drawn, so I'm going to subtract my 8. I have 24 valence electrons left. Now to make this a little easier, I'm just going to make my pen larger so I can just draw dots. And my third step, I believe, let me make sure, step 3 is, yes, complete the octet on each of the bonded atoms. So this chlorine right now, I'm talking about the one on the left, if you look at it, has 1 bond, that's 2 electrons. So I'm going to start counting at 3, 4, 5, 6, 7, 8. That chlorine now has 8, including, and I'm going to erase these in a second, the 2 that are in that bond. It's being shared, but we can count that chlorine as having all 8 of those. If you think about it, each of the other chlorines is going to be the same. So I'm going to put 6 more valence electrons on each of the chlorines to give each of them an octet. And then I'm going to go back to my count here, and if you think about it, you did 6 on each chlorine times 4 chlorines. That's minus 24 electrons, 0 electrons left. Now my next step would be, if you remember, number 4 is check for extras. Well, we've got 0 left, so there are no extras. If there were extras, they would go on the carbon. Very last step, check for an octet on the center. So if you look at our carbon here, and I'm going to go back to my larger pen, this carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Yes, they are being shared. Yes, they are in a bond. Yes, we also counted them for chlorine. Remember, that's the idea of sharing. But that carbon is good. So we're actually not going to need to make any double or triple bonds in this case. And that would be our molecular structure for CCl4. Now, for the sake of the video, we're just going to jam through a whole bunch of examples. So I'm just going to keep going. If you have questions, email me or talk to me in class. H2O, hydrogen has 1 valence electron. So 1 valence electron times the 2 hydrogens gives us 2 valence electrons for hydrogen. Oxygen has 6 valence electrons, so that gives us a grand total of 8. So much less this time. Now to draw our skeleton, remember we said it's the first atom unless that's hydrogen. In this case that applies. So I would draw the oxygen and then distribute the 2 hydrogens off to the sides. Okay, because I drew 2 bonds, 2 electrons per 2 bonds, that's 4 electrons. I'm going to subtract my 4, and I have 4 electrons left. Now I'm not sure if I mentioned this in my my rules at the beginning, but our next step would be complete an octet. There is an exception to that, so I'm actually going to go up and I'm going to write except hydrogen. Hydrogen only ever wants 2 electrons. So like a duet, we won't call it that, but hydrogen only wants 2. So when I look at this step, I'd see, okay, this hydrogen here already has 2 electrons. It's got 2 electrons in that bond it's sharing. So that hydrogen is good. The same applies to the other side. So I'm actually not going to draw any more valence electrons for my step 3. So I go to the next step. Do I have any extras? Well, yes, I do. I have 4. And I'm going to put them on the center atom. So I put those 4 on the center atom. Subtract the 4. I have none left. And then lastly, I check the oxygen. The oxygen, as you can see, has 4 dots, 4 lone pairs, or 4 lone electrons, and because it has those 2 bonds, we can. So I'm going to label this one more time just to make sure this is clear. We have 2 electrons there, 2 electrons there, 2 in this bond, 2 in that bond. That actually makes 8 total. So this is good. This oxygen is happy. So this is the molecular or the Lewis structure for water. Now, if we're going to talk about the shape of this, so technically, I'm just going to tell you that the shape of this should be drawn like this. Now, we didn't know that at the beginning, but technically this should be redrawn to this structure, and that'll make more sense when we do our lesson on molecular geometries. Moving on to our next one, NO3. Nitrogen has got 5 valence electrons. We've got 3 oxygens times 6 valence electrons each gives us 18 valence electrons. Now, the one exception here is now this thing has a charge. That charge means that this polyatomic ion has gained an electron. So we have to factor that in. So I'm just going to add 1 more electron to factor in the 1 electron that was gained to give this thing a -1 charge. So 5 and 18 and 1 gives us 24 if my math is correct. And then we do the same thing. nitrogen goes in the center because it comes first. And I'm going to spread out my 3 oxygens in kind of a peace sign or an upside down peace sign symbol. And then I'm going to do my subtraction because I drew 3 bonds, 2 electrons per bond. There's 6 electrons. I've got 18 left. I'm going to go back to my dots. I need to complete the octet on each oxygen. 1, 2, 3, 4, 5, 6. Remember, plus the 2 that are already in the bond. Oh, I missed one there. Let's go back. And 6 and 6 and 6, or 6 times 3 is 18. I've got 0 left, so there are no extras to put on the nitrogen. Okay. Now this is an example of when that last step kicks in. That last step was check for an octet on the center. So let's go back and look. And if we are going to count there, how many electrons are on that center nitrogen? If you look, we've got 1, 2, 3, 4, 5, 6, and that's actually short of an octet. So in this case, here's what we're going to do. You pick an oxygen, doesn't matter which one, and we're going to move a pair of its electrons, and we're going to actually make a bond with them. Okay, so I'm going to erase those ones and turn it into a bond. Now if you look, we actually have the same number of electrons as we did before, and I'm going to just do this once to check real quick. But if I'm going to count my 2's, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I still have those original 24. I haven't actually drawn any more valence electrons than I started with, but the thing now is that nitrogen has its 8. It has 4 bonds, so it has its 8 valence electrons. Again, they're being shared, but it's happy that it's got its 8, including sharing. And this oxygen is actually still happy. It's got its 4 valence electrons in the bond and 4 not in the bond. That makes 8 total. Now, because this one is an ion, the last thing we'd want to do is we want to put brackets around the whole thing and the minus charge. So that would be the completed molecular Lewis structure for nitrate. Real quick, almost out of time here. My video thing lets me only record 15 minutes. Do something like oxygen. Oxygen has 6 valence electrons, and 6 valence electrons gives us 12. This one's just kind of funky because there's only 2 of them. So just pick. Let's do an oxygen and an oxygen. For the sake of this, I'm going to call this the center atom, the one on the right. So I'm going to subtract my 2. I've got 10 electrons left. I'm going to complete the octet on the not center atom first. 1, 2, 3, 4, 5, 6. So minus my 6 gives me 4. Again, extras go on the center. 1, 2, 3, 4. Minus 4. I've got 0 electrons left. But then I check my center atom and I see that I don't have enough. So I'm going to, if you can see here, I'm going to erase those 2. And I'm going to move them to be in the center. If you do a count, both those have 8. Very last example.